Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of plane. So as per the problem, determine the equation of the plane that contains the point P and the line r equals 213 plus s parentheses 415. S is a parameter and it can be any real number. For this problem, we can determine the equation of the plane in vector form. So let's start by writing the general equation of a plane in vector form. In this equation, vector r represents the position vector of an unknown point that lies on the plane. Vector r0 represents position vector of a known point that lies on the plane. S and T are parameters and they can be any real number, and vectors A and B are direction vectors for the plane, and vectors A and B should be non-collinear vectors. Now we are given that point P lies on the plane, so we can use point P for position vector R0. Next, we should find the two non-collinear direction vectors for the plane. We are given the equation of the line in vector form and the direction vector of the line is vector 415. Since this line lies in the plane, this direction vector of line can also be the direction vector for the plane. So there is a very important concept we need to understand and memorize. So vector A can be equal to vector 415. Now we have to find direction vector B. For that, we can use the given point P and the point that lies on the line. Position vector 213 represents a point that lies on the line. And since the line lies in the plane, that means the point 213 also lies on the plane. So we can use this point and the other point P to find another direction vector for the plane. So the other direction vector B can be obtained by subtracting the position vectors for these 2 points. So we can do the point 213 minus the given point P. Now we can subtract these vectors by subtracting their x, y and z components. So for x components we do 2 minus -1 which is equal to 3. For y components we do 1 minus 2 which is equal to -1. And for z components we do 3 minus 1 which is equal to 2. So this is direction vector B. And we can see that vectors A and B are not scalar multiples of each other, because if we multiply vector A by a real number, we will not get vector B. That means vectors A and B are non-collinear vectors, and that's one of the conditions that has to be satisfied by the direction vectors. Now we can write the vector equation of the plane. We will use point P for position vector R0. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.